Okay, so let's move on to ions and isotopes. So we kind of saw how electrons are going to be placed in their shells. We know they can hold 2, then 8, then 8. All right, so let's do the same thing here, but let's talk about this first. So what is an ion and isotopes? Well, first it's very important to remember, so let's type this out. Let me change this font a little bit bigger so you guys can see it. Makes it seem like I mean it when you can see it a little bit better. I'm going to stretch this guy out. There we go. All right, so first of all, the number of protons cannot be changed. The number of protons in an atom cannot be changed. It just simply cannot happen. So number of protons, I'll just add in an atom. Should be self-explanatory, but just in case, it cannot be changed. The number of protons in an atom cannot be changed. You're changing all the basic properties of an atom when you change the number of protons. Okay. But that's the protons. There's two other things in there. There's electrons and there's neutrons. Well, we can change the number of electrons and we can change the number of neutrons. So isotopes and ions are changing one or the other. So ions, what are we changing here? What's going to change in an ion? What are we changing? Are we changing electrons? Are we changing neutrons? Well, this is a change in the number of electrons. Good. You guys knew that. Well, we can either add some or we can take some away. If we add electrons, they're going to have more negative charges, so it would be a negatively charged atom. If we start taking away electrons, well, then it's going to have more positive charges than negative charges, so it's going to be a positively charged ion. So let's do this one first. To kind of just double tap this, let's say we're going to do 11 here. Okay, so 11 protons. It's going to have 11 protons when we're done, but we're going to change the number of electrons. So my question to you is, where are these electrons going to go? Where would we put them? Well, let's see. 1. Make sure I got that color filled in. 2. There we go. 1, 2. Right? They can only hold 2 in the first shell. Well, then 3, 4, 5, 6, 7, 8, 9, 10. So that's 2 in the first, 8 in the second. It's a total of 10. But how many do we need? We need 11. We need one more. So where's it going to go? Well, we're going to put it up here. I'm making really big, apparently. So there we go. There's our last electron. But let's say, what would be easiest for this one to do? Is it going to be easier to gain 7 more to have a full outer shell, or easier to lose one? Well, it's going to be easier to lose one, right? So you'd have the same thing over here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It's lost one. We had 11, but it lost one. So there's our 10 electrons. But the thing is, it still has 11 protons. So it's got 11 positive charges, but only 10 negative charges. So is it going to be a positive ion or a negative ion? This is going to be a positive ion. And so we call this a cation. Sometimes I've heard it called Cation, but I call it cation. And the reason I remember it is that I like cats, and when I pet on them, they purr. And that makes me happy. So it's positive because it purrs, and it's a cat, so it's a cation. So cation, this is a positive charged atom. Positively charged atom. Okay, here we go. So by the way, just so you know, this is sodium. Excuse me. There we go. Lowercase a. That's sodium. So that's a positively charged atom. Let's do a negatively charged atom. So let's do chlorine. Chlorine is going to be our example for this guy. So this is going to have, I believe it's 17. Yeah, 17 protons. So how many electrons would it need? Okay, let's go ahead and put them on there. My lovely dot drawing skills. 1, 2, 3, 4, 5, 6. That guy's big. That's okay. We like them anyway. 3, 4, wait, 1, 2, 3, 4, 5, 6, 7. 8, 9, and 10. There's its 10, so it needs 7 more. So 1, 2, 3, 4, 5, 6, 7. I am laughing at my dots. Sorry about that, guys. But you get the basic idea. You can just draw them in dots with a pencil. But there's your 17. All right. So if you look at it, it's got a full shell, and this outer shell, what do you think? It's going to take 1 or lose 7? Well, it's obviously going to take 1 from someplace, right? So when we come over here as well, this is also 17, same thing. But we're going to draw this as the ion. So we need to, I'm going to cheat here. Y'all can draw this however y'all want. This is chlorine. I'm going to copy, and I'm going to paste, and just put it over there. There's our 17 again. Y'all are welcome. But we're missing 1 though, right? We need the 1 weak set because we want a full outer shell, and we're missing 1, so we're going to take 1. Now we have 17 protons, but we have 18 electrons. It's got more electrons, so it's got more of a negative charge. So rather than be a positively charged atom, this is going to be a negatively charged atom. So we call this an anion. An is an anti as against, which is kind of a to negate or a negative thing. And so this is a negatively charged atom. Negatively charged atom. Well, cool. Well, you can imagine now there's some other things that have applied to this. So when we say it's got a charge, what do we really mean? Well, we mean this. Let me go back to this red for a second. So this is our positively charged atom. That means this whole thing has a positive charge. So you've probably seen magnets before, right? A positive and negative side. Well, this would be like a positive side of a magnet. Over here, though, this one's got a negative charge, so it's going to be like the negative side of a magnet. It's going to have a negative charge. What happens when you put a positive magnet next to a negative magnet? Well, they stick together. So guess what happens when you put sodium ions, cations, next to chlorine anions? They stick together. They stick together in such a way they actually are forming a bond. And that's some of the beginnings of chemistry, is having those bonds formed by ions. We call those ionic bonds. We'll actually use this as an example later on for our type of ionic bond. We'll talk about it a little bit more. All right, so that's the change of the number of electrons. Well, let's go see what happens when we change the number of neutrons.